Have you ever wondered how chemists separate alcohol from water? Or how crude oil is transformed into petrol and diesel? The secret is distillation, a powerful technique that separates liquids using heat and boiling points. By the end of this lesson, you should be able to define distillation and explain its purpose, identify and label the key parts of a distillation apparatus, describe simple distillation step by step, explain fractional distillation and why it is needed for mixtures with close boiling points. Let's focus on the definition. Distillation is a physical separation method used to separate liquids in a mixture by heating them. The liquid with the lowest boiling point evaporates first, then the vapor is cooled in a condenser and collected as a purified liquid called the distillate. Now let's focus on the two major types of distillation. First, we will look at simple distillation, which is used for separating liquids that have large differences in their boiling points. In simple distillation, we use the difference in boiling points to separate liquids. First, we set up the apparatus, a heat source warming a flask that connects to a condenser and a receiving container, as the mixture is heated gently. The liquid with the lower boiling point evaporates first. The vapor rises and enters into the condenser, where circulating cold water cools it down. As the vapor loses heat, it condenses back into a liquid. This purified liquid, now called the distillate, drips into the receiver, leaving the higher boiling point substance behind in the flask. Now let's look at the second type of distillation, known as fractional distillation, which is used for separating liquids with close boiling points. Fractional distillation is used when the liquids in a mixture have similar boiling points, making simple distillation less effective. The apparatus looks almost the same, but it includes a fractionating column between the flask and the condenser. As the mixture is heated slowly, both liquids begin to form vapor. The vapors rise through the fractionating column, where they repeatedly evaporate and condense on the surfaces inside the column. Each cycle increases the purity of the vapor with the lower boiling point. When this purified vapor reaches the condenser, the cold water cools it down and it turns back into liquid. Different fractions can be collected by switching the receiving container when the thermometer shows that a new substance is boiling. Ever wondered how we separate mixtures in real life? From making clean drinking water to producing perfumes? These key techniques make it possible. So we have the techniques, what they are used for, and the key idea behind each one. Filtration is used to separate insoluble solids from liquids by passing the mixture through a filter that traps the solid particles. Evaporation is used for heat-stable dissolved solids, where the solvent is removed completely by heating. Crystallization is used to purify dissolved solids by allowing pure crystals to form slowly as the solution cools. Distillation is used to separate miscible liquids by heating the mixture so that one liquid boils first, then condensing its vapor back into a liquid. Distillation has many real-world applications. It is used in the production of alcoholic beverages, where ethanol is purified to achieve the desired concentration. In laboratories and industries, distillation plays a key role in producing purified water free from impurities. Fractional distillation is essential in the petroleum industry, where crude oil is separated into useful products such as petrol, diesel, and kerosene. The technique is also used to extract essential oils from plants, capturing their fragrances and therapeutic compounds. In pharmaceutical industries, distillation helps produce high-purity chemicals needed for medicines and other specialized products. Here are the key takeaways from today's video. Distillation separates liquids using boiling and condensation. Simple distillation is used when boiling points are far apart. Fractional distillation is used when boiling points are close together. Widely used in laboratories, industries, and everyday processes. The next time you enjoy clean water or fuel your car, remember, distillation made it possible. Join us in our next chemistry lesson. Hello, learners. Feel free to drop by and visit our website for more free resources, worksheets, and tuitions. Visit us at www.anselhillacademy.co.uk today to get started, and subscribe for more updates, tips, and learning materials.